everybody. Today I'm gonna show you your book real quick and just point out what parts of chapter 1 I want to emphasize that you make sure you understand. It's a big book. There's a lot of sections. We won't be covering everything in great detail in lecture. I know you have a lot of classes you're studying for and a lot of books to read, and I just think it'll be easier for you if your instructor sits down and says, hey, look, this chapter, and this chapter, in these sections, these are the ones you really want to focus your attention, make sure you understand. So that's the goal of today and all videos like this. First, this is our book. This book is freely available through OpenStax. And that means that you can download the PDF. That does not mean that you get a free physical copy of the book. So if you want a copy of this book, you need to buy it on Amazon. Otherwise, you can download the PDF for free and take it to FedEx Kinko's, have them print it out. You would pay, obviously, to have it printed, but there's no copyright on it that's going to stop you from printing it out wherever you want. So the beauty of that is it makes it very affordable. Even this physical copy is very affordable. But the disadvantage is when you want to reference constants and stuff that you would reference normally would be on the inside of the cover. You're going to have to kind of hunt through the appendices instead in this textbook because it's meant to be printed. Like they made it so you could print it out. And obviously if the interior of the covers are an integral part of the book, that's going to be a problem. So constants like this one, fundamental constants, are back in appendices. You can hunt back here for them. They are very useful. So you want to know where those are. If you're printing it out, you want to print those out so you have them available in physical form. If you have an alternative book, say this book or a book like it, you would open it up and you'll see that inside just the cover are the major constants that you would be using in the text. So that's really useful, to know where they are, but in ours you have to hunt a little bit more. So if you have the physical book, you may want to just tag those pages with a bookmark. In terms of having a physical book, I recommend highly having a physical book. Please get a physical book, either this one or print it out so that you have physical pages and then bind them together yourself in little notebooks so you have them all together. It is going to make all the difference in the world for you in terms of how well you do in this course and how well you understand physics. Because as much as we can cover in lecture, it's just not very much, honestly. Like, we don't have a lot of time in lecture. And so for you to really understand all of the concepts, you're going to have to crack open a book, this book or another book, and actually read the sections because you're going to get so much more detail. And in fact, having multiple books is even better. Have the 2 books. If you can get your hands on somebody's old physics book, you just want to go for your university physics, then you will have an opportunity to read 2 different authors' ways of writing something, and maybe one of them will resonate for you more than the other. You'll also get extra practice problems by having multiple books, which is very useful as well. So in this book, in chapter 1, I just want to point out the sections that you really want to make sure you fully understand. The sections, that doesn't mean that the other sections aren't any good. The other sections are all very good, but the sections of the most importance are the ones I'm going to point out. So you want to make sure that you know units of time, length, and mass. And I'm assuming you probably already know these, which is why we don't spend a lot of time in lecture on it, which is why if you aren't too familiar with them, you need to read this section. Metric prefixes. This will tell you the words we use for the prefixes, and we cover this in lecture as well, but we do it quickly, so make sure that you're familiar with this section, very familiar and able to do it. Unit conversions. Most of the things in chapter 1 here, I'm assuming you've already seen in some previous course. So we don't spend a huge amount of time in lecture on them. we will cover this, and we pretty much do it exactly like the book states it. This is my preferred method for doing unit conversions. So make sure you understand that. In particular, notice right here when you're converting something that is raised to a power of 3, how you deal with that. Or raised to any power, power of 2, power of 10, whatever you're doing, you got to make sure that you're taking count of that power in your conversion and how to do it properly, because that's a really common mistake. Dimensional analysis is 1.4. Dimensional analysis is hugely vital to your grade in this course. It will tell you when you make a mistake ahead of time generally. Super important. So the way they introduce it here in the text is very symbolic. Not to say that the way I do it isn't symbolic, but this is like one extra level of symbolism. So they're using L for length and capital M for mass, and then it's very mathematical. They'd raise it to the power of 0. That's kind of crazy. So in lecture, we're going to go over this, and I'll show you how I do it, which utilizes units instead, and I think is much more straightforward. And also it just happens as you're doing your calculations, so you're not doing a separate one on the side necessarily. So dimensional analysis, very, very important. The way they do it, I think, is particularly hard to understand, and unless it clicks for you. I'm sure if I was a student, that would not click for me. But anyway, don't think that it's not very important, and I'll show you a way in lecture to do it that's, I think, more transparent. And that's pretty much it for chapter 1 in terms of the really vital things that you understand. If you're going to go on and be a physicist, or you're very interested in possibly becoming a physicist, I recommend reading the whole chapter. In particular, Fermi calculations. These are very popular amongst the physics culture. So you will find physicists love to do these. And this is the back of hand estimates. Once you get pretty good at them, which if you want to go along in physics, I recommend getting pretty good at them. Not only will it wow your friends at parties, but it might win you some sort of prize when you estimate the number of jelly beans in a jar really accurately. The rest of this, sig figs, accuracy, precision, these things are important, but I'm not going to heavily grade you upon them. So everything I'm pointing out are the things you have to be able to do, the things that I pointed out with my little pink, oh, you can't see them, I have little pink flags. Those are the things that throughout these video segments, my hope is to point out the things that are really vitally important for you to be able to do the physics. So the actual computation of the physics. There's additional stuff in the chapters that are really cool, like Fermi estimates. Those are things that if you're going to be a physicist are worth your time. But the things I'm pointing out are just hopefully so that you can minimize the amount of reading you have to do and really focus on the important bits to get your work done in this class. Problem solving physics 1.7. Okay, this is super duper important, although we end up going through this so many times in various ways within the class that breeze through it, but no, we cover it over and over in various different ways, and it kind of depends on which problem you're doing as well. So, and that is it for chapter 1. So a very quick video just to kind of get your bearings on chapter 1. I'll do another one for the next chapter, and hopefully I'll continue it through all the chapters, just give you, as you're studying for lecture and your homework, different segments within the chapter that are really important. All right, see you next time.